We started this last section talking about functions. We took a bit of a step sideways to look at the domain and range. The domain was describing the permitted x values, and the y, the range, was the values that corresponded to x. But how do we know when we're looking at a graph whether we're or not we're looking at a function? We use something called the vertical line test. Oh, now I got line twice. The vertical line test. We know that the graph of a vertical line intersects the graph of a function exactly once. So no matter where you draw a vertical line, if we are looking at a function, it will only intersect the graph once. So if we look at this first example here, I can draw any vertical line, and every time it only intersects the graph once. This is a function. If I look at my second example, the vertical line is intersecting the graph exactly once. Yes, this is a function. Pause your video and decide whether these two graphs are functions or not. When I draw a vertical line here, I see it intersects the graph more than once. This is not a function. Here, any vertical line intersects once. This is a function. So we can tell by looking at a graph pretty quickly whether or not we're looking at a function. How can we tell when we're looking at an equation whether or not it is a function? Well, we use something called function notation. So remember we said that all linear equations are functions? X is the input, Y is the output. We would write our linear equation in slope-intercept form. Now, sometimes we forget when we're looking at slope-intercept form, is it a function? So we've decided to be really specific in mathematics. And whenever we have a function, we replace y with the f of x. Now, I'm using x because this x is in the equation. Oops, that was y equals mx. There we go. If I had f of r, then this would say equals mr plus b. That x just tells me what variable we're using. But in functions, we tend to use x in our function, not always. So what does that mean? Well, we just use substitution. Look here. We have an x, but when I write a, I'm asking you to find the f of 4. We changed x to 4. That means we're going to change the other x to 4 as well. So the f of 4 equals 11. What this tells me is that this is a function, and when x equals 4, y, or the f of x, equals 11. Let's try another one. This time, we've changed x to -3. So we had x here, we had x here. Every x becomes -3. every x becomes -3. Now, I did say up top here that every solution also gives us an ordered pair. It depends what's being asked for. If you're asked to evaluate, the answer here is 11. The answer here is -3. But if you're asked to find the ordered pair, remember we're looking for x and y. Well, in this question, x is 4, y is 11. X is -3, y is -3. Try question 2A, but just evaluate it. Don't find the ordered pair yet. Pause your video, give that a try. I hope you noticed that there were 2 x's. Remember, we have to change every x. X became 4. So every x in our equation has to become 4. Using order of operations, 48 minus 8, this equals 40. Now pause your video, write down the ordered pair that we've found. X is 4, y is 40. Pause your video, evaluate the f of -3. All of the x's become -3. (27 plus 6 is 33. Did you find the ordered pair? I think the hardest thing about evaluating functions is getting your substitution right, remembering that every x has to become the value that we have inside our f. Pause your video, try question 3. Did you get -6? Pause your video again. Did you get -24? And what about your ordered pair? Now, question 4 is interesting. There's no x in our equation. It just says the f of x equals 5. Well, I change x to 0, but there's no other x to change. All I have is equals 5. This tells me when x is 0, y is 5. What do you think about the next one, part B? I'm still using this equation, f of x, in this case, f of -3 equals 5. This tells me when x is -3, y is 5. It's tricky, that one. There's no substituting to do. We should talk about the absolute value function. We talked about this when we were looking at adding and subtracting integers. I told you that absolute value describes the distance from 0. Now I want to give you the mathematical definition. This definition says that the absolute value of x equals x if x is greater than or equal to 0. But the absolute value of x equals the opposite of x if x is less than 0. That's a little bit tricky. Let's try that. So we've got our x here and here, and now we've changed x to -1. So we've got -1 in here. -1 is less than 0. That means I want the opposite of x. Well, remember what we said before, it's just the positive value. The absolute value of -1 is +1. What about the f of 1? Again, we've changed x. So we're going to need to change all of the x's. The absolute value of 1. Well, this time we have x is greater than 0. That means we just keep x. This equals 1. So it doesn't matter what we put inside the absolute value sign, we always have a positive value that comes out. We didn't talk about the ordered pairs. Remember that this is our x. What comes out is our y. This is our x. What comes out, this is our x. What comes out is our y. So here x is -1, y is 1, x is 1, y is 1. Why don't you pause your video and try the last question here. We're still using this equation. The absolute value of 3 equals 3. The absolute value of -3 also equals 3. If you wrote those answers, that is correct. What is the ordered pair from part C? When x is 3, y is 3. What is the ordered pair for D? When x is -3, y is 3. Spend some time working on those functions. Make sure you complete your quizzes by their due date, and make sure you have the date for test 1 in your calendar.